All right, welcome to Unit 6 on Inference for Categorical Data, working with proportions. In this video, we are going to tackle an example from topic 6.2, constructing a confidence interval for a population proportion. So in the previous video, hopefully you learned a lot about how to construct a confidence interval and what it's all about. Let's actually put all that to work now. All right, marine biologists have been noticing that more and more aquatic sea fans are becoming infected with a bacterial fungus that is causing the sea fans to die off in extreme numbers. All right, if you don't know what an aquatic sea fan is, maybe take a second and Google it. But it's, I don't want to say it's an underwater tree, but it's like an underwater plant, and they're very beautiful, majestic looking organisms here. But anyway, like any other organism, sometimes they get infected with a disease. So to estimate the proportion of infected sea fans, researchers select a random sample of 55 sea fans throughout the Atlantic Ocean. Of the 55 they discovered, 12 were infected. So let's create a 95% confidence interval for the estimate, the population proportion of infected sea fans. All right, so to be honest, we're going to go through all 4 steps, but the only thing you really need to construct the interval are 3 numbers. The first number we need is a p-hat, a sample proportion. And we knew that 12 of the 55 sea fans were infected. So we do need a proportion. Remember, you can use a fraction. There's no harm in using a fraction. A fraction, by definition, is a proportion. But most people go ahead and divide it out to get a decimal. So it's 0.2182. So that was what our sample showed. The other number we need is our sample size of 55. And the only other number we need is our z-star. This is simply how far we're going to reach, how many standard errors we're going to reach in both directions to try to capture the truth. Now remember, this is contingent on how confident we want to be. So we talked about this in the previous video, but if we're 95% confident, that means that 95% of sample, that's a really bad normal model, I'm sorry. That means that 95% of samples are in the middle. That puts 2.5% at the bottom that are significant, 2.5% at the top that are significant. So to get the z-star, the easiest way is to use your TI-84 calculator and do an invert norm of the bottom 2.5%, and you get 1.9600 as your z-star. Again, we talked about how to calculate that in the previous video. Now with those 3 numbers, it's really easy to calculate, actually construct a confidence interval, but let's actually go through all 4 steps, because knowing all 4 steps is really important. The first step is that you have to clearly state the name of the interval you are finding. This is called a one sample z interval for a proportion. And the proportion we are trying to find is the population proportion of infected sea fans in the Atlantic Ocean. So don't forget to use that context and be very, very specific. So we are using a one sample z interval to estimate the proportion of infected sea fans in the Atlantic Ocean. Okay, I know this seems kind of like I don't want to say a silly step, but it's really important that you know the name, a one proportion z interval for a proportion. Over the next couple lessons, we are going to learn more and more intervals, and they are a little bit different, so that's why we have to know the names of them. And this one is called a one sample because we only looked at one sample, and it's called a z interval because we're using our special z stars, and it's obviously for a proportion. All right, now the second step is to check the conditions. Now this is super important, and I explained this in the previous video as well. We're not actually building a sampling distribution because we do not know the true proportion. But we have to at least imagine that that sampling distribution does exist. So if we're thinking about the existence of that sampling distributions, we do need to make sure that our sample is random to avoid any bias. We need to make sure that the 55 sea fans in our sample is less than 10% of all sea fans in the Atlantic Ocean to assume independence. And we also have to make sure that our sample is big enough to utilize the normal model. So what is big enough? 10 or more successes, infected sea fans, and 10 or more non-infected sea fans, failures. So our sample was said to have 12 infected sea fans, and obviously with 55 total, that means that 43 were not infected. So both of those samples, the successes, the failures, were bigger than 10, so we could utilize the normal model. All right, so some kids like to write this as a paragraph like I just did. Others prefer to use like bullet points, 1 bullet point for each condition, whatever, I don't care, but make sure that they are well written and that they are in context of the problem. The third step is actually quite easy. It's actually doing the work to build the formula. Please make sure that you write down the formula first. So the formula is simply taking our p-hat and adding or subtracting this back part. Remember, this back part is called the margin of error. And that is your Z star times the standard error. Again, we talked about what standard error is in class or in the previous video. So our p hat was 0.2182. We're going to go up or down. We're going to find our margin of error. Margin of error is the Z star that we found earlier, 1.96, times the standard error, which is taking the p hat, 0.2182, times the opposite of p hat, which is 0.7818, and dividing that by the sample size of 55. Now, again, you could use your calculator and just dump all that in one type. Just type 1.96 times the square root of 0.2182 times 0.7818 divided by 55. Just make sure that whole back part is in parentheses, and you get the margin of error. The margin of error is how much I'm going to add and subtract, and that is 0.1092. So I'm going to take the 0.2182, I'm going to add 0.1092 to get 0.3274, subtract 0.1092 to get 0.109. So those are the two sides of my interval, the left and right of my interval. So now the fourth step is to simply explain in context what this interval says. So I'm 95% confident that the true proportion of infected sea fans in the Atlantic Ocean, notice how specific I'm being there in context, is between 10.92% and 32.74%. Okay? Actually, as I look back here, it was 0.109. So I'm sorry, it should be from 10.9%. So 10.90%. So minor detail, but it should be a 0 right there. So again, I don't know what is the true proportion of infected sea fans in the Atlantic Ocean, but I do know based on my confidence interval that the true answer is somewhere between 10.90% and 32.74%. So if I'm a scientist and I'm concerned about the percentage of infected sea fans in the Atlantic Ocean, I could at least narrow it down to somewhere in this interval with 95% confidence. All right, that's a nice, really quick video that just runs through the 4 basic steps to construct a confidence interval. Please make sure on any problem you do all 4 steps. Please, you got to do it. It's worth the work. It's not that difficult. Each step is individually pretty simple. Put them all together. Yes, you got a little bit of work to do, but overly, it's really not that difficult. All right, guys, that's it for this video. Hope this was a simple demonstration of how to construct a 1 sample Z interval for a proportion.